Okay, so here we are moving on to TurboTax, and number 8 says, given 3K2SO4, how many molecules are there? So we have this K2SO4, and this 3 right here on the left-hand side is what we call the coefficient. Alright, it's how many of all of these we've got. So how many molecules of K2SO4 do we have? We have 3. Alright, how many total potassium atoms are there? So to find out how many of these there are, in each molecule there's 2 potassium atoms, but there's 3 of those. So we distribute this 3 out. 3 times 2 is 6. So there are 6 potassium atoms. Alright, how many total oxygen atoms are there? Well, for each molecule there's 4 oxygen atoms, but we have 3 of those sets of 4. So 3 times 4 is 12. Okay? Give the reaction notation. So basically, to give a reaction notation, we take this coefficient and distribute it to all the parts of our molecule. So 3 times 2 is 6, so we end up with K6, and then S times, there's one of these, times 3, we end up with S3, and then O12. Okay? And then here, for number 9, we are balancing the following reactions. So we have aluminum and chlorine, sodium and, I believe, carbonate, and then aluminum and carbonate and NaCl. So we have to have the same number of each of these on the left side as we do on the right. Well, if we start here on this right side, we have 2 aluminums. We have Al2. On the right, or the left side, we only have 1 aluminum so far. So we can start by putting a 2 here. Alright, when we put a 2 here, our Cl, there's 3 of them, but now we have 2 sets of 3, so 6. So over here where we have a Cl, it's actually got nothing over here, so we have to write a whole 6 on this side, which creates 6 sodium, 6 Na. So we go back over here. Well, over here we have Na2. So we need a number that's going to, when multiplied by 2, we get 6. We want a total of 6 sodiums. So that number is going to be 3. Alright, so then we end up with 3 of this CO3. And we already have 3 of these CO3s. And we already have 2 aluminums based on the left side. So we can actually just put a 1 here. Okay, and then just to recap, we have 2 Als on both sides, 6 chlorines, 6 sodiums on both sides, and 3 CO3s. Alright, now for the second one, we have iron and oxygen, and then iron and oxygen together. Over here, we have 2 irons. Over here, we've got just 1. Here we have 3 oxygens, and only here we have 2 oxygens. Well, 2 and 3 oxygens, basically we're going to have to find a common number to multiply it by to get the same number of oxygens here. So if we multiply, say, this 3 by 2, if we put a 2 out front, we would have 6 oxygens. So is there a number we can multiply by 2 to get 6 oxygens? Yeah, we could put 3 here. But now we have to worry about iron. We had 2 iron, and then we have 2 sets of 2. So we have 4 irons. So then we come over here and put a 4 in front. Make sure that we have matching sides, 4 irons, 2 times 2, 4 irons, 3 times 2, 6 oxygens, 2 times 3, 6 oxygens. And we're done.